This is the priority queue of integers. Similarly, we can also create a priority queue of strings, and we can add elements, right? We can add elements to the queue, but a priority queue removes elements from head pointer, but elements are maintained in sorting order, right? But elements are removed from head pointer. That's what priority queue works. That's what in the last class we discussed. And we can also pass comparator as a parameter while creating a priority queue object. While constructing a priority queue, we can pass comparator as a parameter. So this is priority queue of integers. Generally, we don't work with integers or strings in priority queue or any collection. We always use collection to perform operations on custom objects like employees, customers, orders, something like that. Okay. So what we do now, I want to create one class on top of this now. Let's say, for example, we want to discuss okay, well, let's create one class called as order class, which contains order ID, order date. Okay, order ID, order date, and delivery date. And the priority queue should maintain all these orders based on the delivery date. Okay, based on the delivery date. So we want to maintain the orders in delivery date order. For that, we create a comparator object. Okay, and based on the priority or based on the delivery date, the orders must be delivered. If order is delivered, that order must be removed from queue. So for that, what we do is we write some code here today. We don't work with the priority queue of integers or strings. This is only a small code just to know. But actually, we want to start creating with the user-defined class. Let's say we are creating a class called as, let's say, for example, I'm creating a class called as class order. Order is a class. And which contains attributes like private, int order ID. And private local date is a class. Let's say order date. And I'll take, for example, private, again, local date, delivery date. Local date is a class in Java, which is to represent date, not the time, only date, delivery date. Okay. So basically what I'm trying to say is, there are three attributes to my order. One is order ID, order date, and delivery date. Okay. So the thing, what I want to do is now, okay, what I want to do now, I just want to sort them according to delivery date. Okay, according to delivery date, I just want to sort them. And I want to maintain them in a priority queue. The priority queue should maintain the orders in the priority order of the delivery dates. So for that, we are creating one class called as order, and we have the attributes like this. And then we want to define a constructor. We want to define setter, getters. So let's create one constructor. We'll go to source, then we define constructor using fields. Okay, and after the constructor, then we want to define setter and getter, then toString method. Okay, all. We want to generate getter and setters for all these fields. Then also we want to define, sorry, we want to go to source and we want to generate what, guys, we want to create what, toString method. We want to override toString method. This is my one class called as order class. Next, I want to create a comparator. For example, I'm writing class, you know already how to define comparator. Let's say, for example, delivery date comparator. delivery date comparator implements comparator. Implements comparator of order. Comparator of order. Next. We have to override this method here. We know comparator is an interface, so obviously we need to override the method. The method which I want to override is called compare. We want to compare the delivery dates. So return O1 dot get a delivery date dot compare to O2 dot get delivery date. Okay. We are getting one comparator. Once this comparator is done, now actually we want to now start creating this priority queue object. We are passing new delivery date comparator as a parameter. Means object of comparator we are passing as a parameter. So delivery date comparator is the parameter. Okay, new delivery date comparator is a parameter. Delivery date comparator is a class. So it's giving me an error. Let's see. Cannot infer type arguments of type priority queue. This is of order, right? Now, sorry. Now look at this. Now I have created a priority queue object. I'll remove all this for loop also. But now I need to add order objects. Order objects means I need to pass order ID, order date, and delivery date. So, say for example, PQ dot add of new order. We are passing the order object. Order ID is 101. Okay, order ID is 101. Order date is local date dot of. Local date object can be created by using a class called as local date dot of. We need to pass year, month, and day of month. Year 2014. Sorry, 2024. Next month, let's say August, that is 8. And let's say, for example, date is, let's say, for example, 11. Order date is 11th. Let's say delivery date is 16th. So local date dot of. Okay, year 2024. Delivery date is 16. Sorry, month is 8. Delivery date is 16. Now this is one order. Let's create like that 3 to 4 orders. Let's copy this. Okay, let's copy this. Now what I can say now, local date out of, suppose order date is, order ID is 103. That is order ID 103. And it is ordered on 12th August. And the delivery date is 18th. This order ID is 102. Okay, it is ordered on 13th, but the delivery date is 15th. Okay, delivery date is 15th. I have created 3 order objects. Okay, now let's just display one by one order. We'll see in which priority these orders are got stored in the priority queue. So we can start for each loop for order, colon, PQ, priority queue, or orders queue. Suppose if I remove this PQ, I mean variable name can be PQ. Let's say system.out.println of order. We have to run this program. Let's check this. You know, orders are managed. Actually, orders should maintain according to delivery date. So delivery date 15th is okay. Next 18th we are getting. Next 16th we are getting. Actually, we should get 15th after 16th, then 18th. 18th should come last because delivery date 18th is last order. I mean, say that the last priority. But 15th is the first priority, 16th is second priority, 18th is last priority. Okay. Now I need to check this. Okay. Okay. We'll keep this code currently. Like yesterday also we got something like this. We are passing delivery date comparator, but still we are comparing the delivery dates, and our intention is 15th should come first, 16th should come next, 18th should come last. Right?
While
Okay.
removing it will come in order, sir.
At the time of removing, but at the time of displaying, the displaying in a different order, right? Okay. We will do one thing. First, there are three orders. No? We'll do one thing. What I will do is PQ dot poll, POLL. Actually, poll is nothing but it will retrieve and remove the head of this queue and returns null if the queue is empty, right?
Yes, sir.
Okay. So first I'm calling PQ dot poll. Poll means remove the order from the head of the queue. Head of the queue is 15. So first time I'm calling poll here. If 15 is removed, then remaining are 16 and 18. We have remaining two orders here. Then we'll do one thing. Just will start removing one by one order to check it now, whether while removing, is it going to maintain a priority order or not? Okay. Just we want to use a separator. This is first poll operation. Let's see the second poll operation, that is called PQ dot poll. Again from head of the queue. Then again we want display the orders now. Okay, now let's check. If I run this program, if the 15th is removed, remaining all 16 and 18. Next, if delivered date 16 is removed, then remaining is 18 only, because two times I'm calling the poll operation. So let's see how we are going to get the output. Okay, right. Now, if you look at this, at the time of removal, when I'm calling poll operation, first time 15th is removed. But again, when I'm calling poll operation, 16th is removed. That's why I'm getting output as 18. So first time when 15 is removed, remaining orders are 16 and 18. Because from head of the queue, what is removed? 15th is removed. Now there are 16th and 18th delivery dates are there. Again, if 16th is delivered, we are calling poll operation so that from head of the queue that is removed. But displaying, we are getting in a different order. But actually, at the time of removal, it is maintaining the priority order only. Correct. So now the delivered date is 18. Okay, because 16th is removed. First poll operation removes 15th date. Second poll operation removes 16th date. The remaining delivery is order is 18th. It is going to be delivered on tomorrow, 18th. Once it is delivered, we will remove this from queue. Okay. This is how this priority queue you can understand. Okay. I will just copy this code for you. Just try to execute this code. Here I am creating comparator. Otherwise, our elements must be comparable elements so that elements are sorted in natural sorting order. Okay. You know the difference between comparable and comparator. If you want to sort the elements based on multiple, different fields each time, then we should get that many number of comparators. If I use comparable, I can only just sort based on one field. But if you want to sort sometimes based on field 1, sometimes based on field 2, sometimes based on field 3, then you have to create multiple comparators. We know comparable and comparator both will play a key role in collections for sorting the elements. Okay, so this is simple example code to check with priority queue. Priority queue. Okay, that. This is a sample code that you can check with the priority queue. First time we called poll operation so that 15th date is removed. Next time we called again poll operation. It will remove from head of the queue, that is 60. And first time this loop will print two orders, 16th and 18th day delivery dates. This for loop will next print only 18th order because we removed from head of the queue 16th. Okay, that's how the priority queue is working. Next. Okay, guys, we got something like in the hierarchy priority queue. Okay, I told queue linked list is also class, which also implements queue. Linked list class implements list interface, and a linked list class also implements queue interface. Next, we have something called as blocking queue. Actually, blocking queue is an interface. It has multiple implementation classes, but one of them is array blocking queue, other one is priority blocking queue. Okay. Right, guys. One is blocking queue. What I'm saying, blocking queue contains array blocking queue and priority blocking queue are the two implementation classes of blocking queue interface. So first we'll go ahead with the array blocking queue, then we'll go ahead with the, just to know about how it works. So basically blocking queue will be used in multi-threading applications. Sometimes what we need is, first we want to create a queue with some capacity. And we want to block the threads. For example, two threads are working on the same queue. Okay, suppose we want to block the thread. If a thread actually trying to add a element to the queue, but the queue is full, then we want to block the thread until space is available. And for example, a thread wants to remove an element from the blocking queue, but the queue is empty. Then we want to block the thread until element becomes available. So if at all you want to block the threads, okay, when they are performing add operation or remove operation, if you want to block the threads when the queue is empty or when the queue is full, then we should go for blocking queue. Okay, let's say while creating array blocking queue object, I created with the capacity 5. Already 5 elements are there. A thread is trying to, this is used in multi-threading applications, like especially while working with the producer consumer applications. There is a producer thread which is producing some element. Okay, what happens now? When the producer thread is producing an element, it should store that element in a queue. Producer thread wants to store the produce element in a queue, but the queue is already full. Then we want to make that producer thread to wait until space becomes available in the queue. Until space becomes available, we want to make that producer thread to be in waiting. We want to block it so that it can't produce next elements. It is waiting. And when there is some space got available, then this producer thread can store that element in a queue. Similarly, when consumer thread is trying to read an element or get an element from the queue, if the queue is empty, then we want to make the consumer thread to wait until at least one element is added to the queue. Because without adding any elements in a queue, without having elements in queue, when the queue is empty, consumer thread cannot able to read elements from the queue. We want to block the thread. That's what blocking queue concept. So basically blocking queue will be used in multi-threading applications. Okay, blocking operations are there in blocking queue. There are methods like a put and a take, apart from the remaining methods like add or some other. Okay, and do remember, if you call add method or if you call poll method, they won't block the threads. But there are two methods which are given to make the threads to block. And they are called, one is a put method and other one is put off element and a take. Take means retrieval and removing the element. Okay, so let's see. There are two blocking operations are there in blocking queue. One is called put method and other one is take method. So let's see how it works. Let us first go ahead with the blocking queue. In blocking queue, okay, you can see there are methods here. In the methods, you can see put method is there, take method. Remaining methods are, we know, add method is there, offer method is there. There are for adding only. Put method is there, offer method again with some different parameters. But you see the put method is going to block. Remove method is there, poll method is there, just now we used. Take method is there. Take method will block. So take method, poll method, remove method, all are to remove only in a blocking queue. But you know, remove method throws exception. Poll method returns null. Special value means null. Okay, null is called a special value in Java. True, false, null are called special values. Take method will block the thread. Okay, right? But when you come to, when you want to examine means you want to retrieve only, don't remove. Retrieve but does not remove. Element is a method, peek is a method. And we don't have any applicable methods for blocking. There are two methods which can make a thread to block. One is put method, next one is take method. If a thread is calling add method or offer method, the thread is not blocked. But from the thread, when put method is called on a queue, then the thread gets blocked if the queue is full. No space is available, right? Take method will throw, take method will make the thread to block because the queue is empty. Okay, right? This is how the blocking queue works. It's an interface called blocking queue which extends queue. Okay, it is a queue that additionally supports operations that wait for the queue to become non-empty when retrieving an element and wait for space to become available in the queue when storing the element. This is how the same definition we'll also add to our blocking queue. It is a queue that additionally supports operations that wait for the queue to become non-empty while retrieving an element and wait for space to become available in the queue when storing an element. Who are the blocking operations? Put and take. This is called blocking queue. And what are the implementation classes? There is an array blocking queue. There is an array blocking queue. There is a priority blocking queue. And these are all linked blocking queue. Okay, right? So generally we use array blocking queue. Just if you know one or two implementations, that is enough. One is called array blocking queue. Other one is priority blocking queue. Okay, right? We'll see. But thing is now I cannot write a code for this now because what I can say in multi-threading, I'll explain about this example. Currently, I'm only just giving some information about regarding blocking queue, but we'll revisit the blocking queue in multi-threading because we will create one thread which is like a producer thread which will produce an element, and we'll use a blocking queue there, and a consumer element which will retrieve the element. And there we will do one thing. We will create a consumer thread to retrieve an element, and we'll see whether producer thread is waiting when the queue is full, and we'll see when consumer thread is waiting when the queue is empty. At that time, we'll discuss about blocking queue. Okay. Currently, just only I'm showing you what methods of blocking queue will make the threads to block. Okay. One is put method. Second one is take method. Okay. And at that time, we'll use array blocking queue implementation class or priority blocking queue, any one of the two implementation classes we can use. But this is the information about blocking queue I want to give you. Okay, but I'm not going into anything details of blocking queue. Example, because if in multi-threading only we can understand, otherwise we can't understand about how to work with a blocking queue. But sure, in multi-threading, I'll explain an example on blocking queue. Now, let's come back to our notes now. This part we are going to look at in what is that called in multi-threading to understand, but you got an information about what blocking queue is all about. Now I want to talk about the other type of collection that is called map interface in Java. Okay, so already we know about hash map, linked hash map, and tree map. Just I want to give you the map hierarchy. Map is also one more type of collection. Whenever you want to store the data in a key and value pairs, then in Java, then you have to use an interface called as map. Map is also one type of collection, but it is not directly an interface inherited from collection. We have only three interfaces from collection interface. One is list, other one is set, and the other one is queue. Okay. So, but map is another collection type in Java, and where you can store the elements in key and value pairs. For example, if you take list or set or queue, elements are nothing but single objects. Of course, the set internally uses map, but to the set we are adding just element only. But if you want to store elements in key and value pairs, okay, then we need to, for example, I want to store a student ID as a key and that student details object as a value. Student ID is a key. That student ID is a key used to identify the student details object. So if you want to store the data like that in key and value pairs, for example, in strings, for example, I want to use IND is a key to refer the value India, a string. I want to use a string AUS as a key to refer country name Australia. So if you want to store the data like a key and value pairs format, then we should go for map object. That's a special type of collection in Java. So let's see the map interface, and we look at about map kind of things. Blocking queue example, I'll tell you at the time of working with multi-threading. So when you talk about map interface, as we know that map can store the data in a key and value pairs. So we'll start here. Okay. What I'm saying is we want to store the elements in key value pair. So basically, map is or java.util.map. Better, I'm writing fully qualified name. Java.util.map interface is a special type of collection in Java where it can store elements in key value pairs. I'll say key dash value, nothing but key value pairs, where you can store elements in key value pairs. Okay. If you talk about map hierarchy, of course, the common thing is when you are storing elements in key value pairs, key cannot be duplicated, but value can be duplicated. Duplicate keys are not allowed in a map. Suppose if the same key cannot exist, we cannot store a key value pair with an existing key. If you are storing like that, you won't get any error or exception, but the value gets overridden. If there is any existing values there for that key, that value will be overridden with the new value that we are adding now. That's how it works, but it won't throw any exception. Okay, so basically, what I can say that key cannot be duplicated, value can be duplicated. We can store null as a key, but how many null values we can store is at most one null value only. We can't store two null values as a key. It is going to become, null is a special value, again it becomes duplicate. That's why we can store only one null value, not multiple null values. We can store only null key at most once. But when it comes to value, you can store null for many times also. Value can be many times null, but a key can be only one time null. Okay. This is another point to consider. So first I won't write my points here. What I'm trying to say is that the key cannot be duplicated, but value can be duplicated. Okay, key cannot be duplicated, but value can be duplicated. Suppose if we are storing an element into the map with a key which is already exists. If you are storing with an element into the map with a key which is already exists, then the new value of the key will override the existing value. But we won't get any exception. We will not get any exception. And one more thing is, at most, we can store. At most, we can store one null key. At most, we can store one null key. Okay. But we can store multiple null values. Values, you can write multiple times null, but key, only one time null. We can't store two null keys. Okay, multiple null values. We can store one null key, but we can store multiple null values. That's a point to understand in map. Okay, let's see the hierarchy first. As you know that map is an interface. So let me write first of all, map is an interface here. Let's say, for example, map is an interface. Some color I'm using. Okay. Let's say, for example, map is an interface. I'll write the hierarchy in this way. Okay, otherwise I'll copy the diagram into this better. Let's say, for example, I'm going ahead with here. What I'm saying is now map is an interface. Okay, map is an interface. So this map interface has implementation classes called hash map. Hash map is a class. Okay, hash map is a class. It is class. Hash map implements map interface. You can see the, let's say, for example, I'm typing here hash map, java.util.hashmap. You know, hash map size by default capacity 16, load factor 0.75. These things we know that, right? So let's say, for example, hash map. Okay, I will show you just a minute. Let's open hash set. From there, we can go to hash map. Okay. We know that hash set Intel uses hash map. So I just want to open the hash map related documentation. That's what I'm trying to see. I'll do that, don't worry. I'll do that, don't worry. We know map is an interface. Map is an interface, okay? Map is a collection of key value pairs. That's why we have two type parameters, k comma v, k for key, v for value. And you know, there is a class called as hash map. Even hash table also. And also there is linked hash map. I'm just opening all the things, and tree map. That's it. Remaining all we don't discuss. Only 3 classes or 4 classes then. Hash map. Hash map is a class. And a hash map class actually implements map interface. Similarly, linked hash map is a class. Linked hash map extends hash map, which means linked hash map is a subclass of hash map. Okay. It implements map interface, of course, but it is extending hash map. Hash map is a parent class of linked hash map. Like linked hash set is a parent. Linked hash set is a child class of hash set. Similarly, linked hash map is a child class of hash map. Then we have something called as a tree map. Along with that, we have one more class called as hash table. Actually, hash table class extends dictionary class. It implements map. So dictionary is one more class. There is a class called as dictionary. Dictionary is a class. It's not implementing any map. It extends directly object. So that's okay. Which means a hash table also implementation of map interface. It implements map. It also extends one more class called dictionary. That's okay. Okay, so I just want to draw the hierarchy. Now next to tree map. Actually, tree map implements navigable map. Navigable map extends a sorted map. Sorted map extends map. So already we know about tree set. The same kind of hierarchy applicable here also. So let me draw the hierarchy first. That will be a better one. Let's see how it works. Let's see. That's why we started our discussion here to write the diagram. Okay, we'll go ahead. See here, hash map. Hash map is a class. What I'm saying, linked hash map is a class which extends hash map. So what I'm trying to say now, I want to keep the a thick arrow which is indicating. Okay, the thick arrow which is indicating extends. This is called extends. Class to class extends, but class to interface is implements. Class to interface is implements. I want to draw the diagram like this. This dotted arrow represents implements. This thick arrow implements. Extend represents extends. Okay, right. Hash map implements map interface. Linked hash map extends hash map. Similarly, there is a class called as hash table. Hash table class also implements map interface only. Actually, it extends dictionary class. That's okay. Dictionary is a separate class. Dictionary is a separate class. And the way how I want to represent hash table is like this now. What I'm trying to say is now, there is a class called as hash table. Hash table. Better, I will write something like this. So better here, right? There is a class called as hash table. Hash table only H capital. Hash table is a class. It's not an interface. What I'm saying that hash table class implements map interface. I agree. It also implements map interface. But it also extends a class called as a dictionary. It also extends a class called as a dictionary. Dictionary is a class. Dictionary is a class. Just I want to represent like this now. Hash table class extends dictionary class. But a hash table class implements map interface. Next. There is something called as a sorted map. Sorted map is an interface. It is not a class. Sorted map. It's an interface. You know, interface to interface is extends keyword. Extends I want to represent like a thick arrow. That's what I'm trying to say. Okay. And the next, there is something called as navigable map. That is also one more interface. Navigable map is one more interface. Navigable map, same as the same concept what we discussed in tree set. But there, the names are sorted set, navigable set, and tree set. But here we have names like navigable map, sorted map, and tree map. Next, we have a class called as tree map. Tree map is a class. Tree map is a class. Tree map is a class which implements map interface, navigable map interface. So implements I want represent with a dotted arrow. Okay. But whereas navigable map to sorted map is extents. Extents I want represent with the thick arrow. So basically, this is a hierarchy that you should know. Okay, so first we'll look at about hash map. Then we'll discuss about linked hash map. Okay, first we'll discuss about what are the methods in map interface, because the methods of map interface are commonly applicable for hash map, linked hash map, hash table, and also sorted map, navigable map, and tree map, because it is a parent of the entire hierarchy. Okay, first we'll discuss about hash map, then we'll discuss about linked hash map, then we'll go to hash table, then we'll go to tree map. Okay, so these are the map related things that we need to discuss. So this is a hierarchy. First, I want to keep it in the document. And I just want to add this into the document, guys. Let's go to the document, and here we'll add the picture. Okay, so you are aware of this hierarchy now. Now, first you have to understand about what are the methods of map interface. Let's open that map interface methods. Sorry. Let's open the map interface methods. If you look at the map, there are methods like this now. Of course, clear. These are default methods, whatever you are seeing, these will see in Java 8 features. Okay, default methods, static methods are features from Java 8. Clear is a method, will remove all mappings from this map. Clear is one method. First, how to store we'll discuss now. There is a method called as put. Better I'll start from there. Put is a method. Key, comma, value. Put method is for storing. Associates the specified value with a specified key in this map. Put is a method to store the key value pair. And returns a value as a result. Of course, if you want, you can take it. Put method will store the key value and returns a value. V for value, right? After putting the value in the map, it will return the value. Just it is optional. I mean, you can store that value into a variable, otherwise you can leave it. But it will return the value. That's what put method will do. Put method will just put the key value pair into the map object and returns that value. Return that value which is stored in the map. That's what put method will do. And opposite to put method, we have a get method. To the get method, if you pass the key, it will return the value. Because key will identify the value. It will return the value associated with the given key. If suppose there is no value available with the given key, we don't get exception, but we'll get null. If the map doesn't contain any value associated with the given key, there is no value with this key. There is no value with this key means what? There is no this type of key. Nothing but we'll get null. So put method, get method important. Next, remove method is there. Remove method is to remove the value from this key. If I say remove of key, the key and value, both the pair will get deleted from the map object. And remove method returns a value also. Whatever the value that is removed will return that value. Remove method. So basically, put method will return the value. Remove method will return the value. Get method also will return the value. Remove method is to remove the key value pair. Remove the element from the map object. Put method is to store the element. Element is nothing but key and value here. And get method is to return the value of a specific key. If that key does not exist, returns null. Okay, that's what the three methods will do. And suppose if the key does not exist in remove case, we'll throw an exception. Let's see. Remove. Okay, right? Remove. So if the specified key is null, okay, then we'll get exception called null point exception. Okay, right? So this is called remove method. So basically remove method, what it will do, it will return the value of a specific key. Okay, if in case, okay, if in case this key does not exist, then how can I remove now? We'll get null point exception. Okay, of course, it is returning null, but if you perform any operation, you'll get null point exception. What it returns the value associated with the key are null if there was no mapping for the key. If you perform any operation on null value, then you get null point exception, but remove method doesn't throw directly null point exception. So that is also to be careful. Otherwise, I can say simply if the key does not exist, returns null. That's what remove method will do. Get method also will do the same thing. Put is to store key value pair. Get is to retrieve the value of a key. Remove is to remove. So first let's add the three methods. Then we'll discuss remaining methods. So first we'll start with the methods. Okay. So what methods of map? So map interface methods. Methods of map interface. Okay. So better because these are common methods for hash map, hash table, of course, linked hash map, and even to the tree map for all these classes to work. For all these classes to work. So we'll discuss one by one method. Let's say first method is put. Put of key comma value to store. So it will store this element. Element is nothing but key and value. Stores element. Element nothing but key and value here. Key and value is called element. One element is also called as one entry in map. In the map terminology, one entry. One entry is nothing but it's a combination of key plus value. Key and value combination is called one entry. One entry is called one element. So element I can use a word or entry I can use a word. Any word is correct. So I say stores a key value. Pair, which is called element in brackets I'm writing. Okay, stores a key value pair in the map or into the map object. Into the map object. Returns value. See, it returns value. If you want, you can store the value or otherwise leave it, but returns value after storing. There is a method called get. Only key we are passing. It returns the value associated with the key. Similarly, if this key does not exist, if this key doesn't exist in map, doesn't exist in the map, then returns null. Next, remove method, remove of key. What this will do? Returns. Okay, returns and removes also. Returns and removes the key value pair okay, associated with the key, with the given key from the map object. Okay, same returns null if the key does not exist. So three methods are there. One is put, second one is get, next one is remove. Okay. So basically what you can understand like this. If you take any map, a map will store the data in the form of key value pairs. I have already represented this in the form of diagrams. in hash set. That's why now it is going to become easy for me and you also. It will store the data in the form of key value pairs. This is called one element. One element is nothing but it's a combination of key and value. Okay, each element will store in a bucket. These are called buckets. And you know the default capacity of the buckets 16. The default capacity is 16 of the map, and load factor is 0.75. So bucket indexes are 0 to 15. We know all those things. That's why it's now easy. Okay, this is going to be key. This is going to be value. It'll store the data like this internally, key and value pairs. The map object will store the data like this in the form of key and value pairs. Okay, if I say, for example, put map.put. Okay, for example, IND India. First, what happens now? This IND India will be stored in one bucket. Let's say first bucket index is calculated based on the key now. Based on the key, hash code is calculated. Based on hash code, bucket index is calculated. We know that already. So for example, its place is here, India. Like this. This is called key value pair. Whenever I call put method, it returns this value also to me, India, after storing. After storing in the map, it returns this value called India. But I'm not storing it any variable, but put method returns value also. Put method will return the value after storing. Similarly, get method is return the value of a key. For example, if I'm writing map.get of AUS, but currently I don't have that. Map.get of AUS is a key. But this key does not exist in the map. Returns null. Returns null. For example, if I'm storing in a string variable, string v is equal to like this. Then what's the value of v now? Null. Because there is no key called AUS. For example, if I pass IND, yes, for the value of IND is India. Then v stores India. The variable v stores India string. The value India. That's what get method. Like this, you have to understand. Okay. Right. Next. Let me delete them. Let me explain the other methods too. So 3 methods we got here as of now. Put, get, remove. Whatever important methods are there, that we'll discuss. Now, if you want to check whether map contains any key value pairs or not, isEmpty. IsEmpty method returns true if this map contains no key value mappings. Map is for mapping only, right? We are mapping a key with a value. That's what mapping. Key, we are mapping with value. That's what key value mapping. IsEmpty. IsEmpty returns true if the map contains no elements. Means if the map is empty, if the map contains no key value mappings. Otherwise, returns false. That's what isEmpty. Next, I have to explain key set method. And also there is a method called as values. And we have size. We are going to look at about all these methods now. So first I want to explain now isEmpty. After isEmpty, then we have something called as key set. Actually, key set returns a set of all the keys contained in the map object. So basically, let's go to 3 methods I'll explain here. Let's put our diagram. Let's say, for example, there is a key called AUS, values Australia. Okay, Australia. For example, there is a key called NZ. Let's say, for example, New Zealand. Guys, let's say, for example, there is a key called, there is something key called, okay. Let's say, for example, TH, Thailand. Some key value pairs are there like this. Okay. Let's say, okay. Let's say key is US, Australia, USA. Like this, we have key value pairs. Now requirement is what I want to, now there is a method called key set. Only all the keys will be returned. All the only keys now. All these keys will be returned. All the keys will be returned. What happened is, okay, just a minute. To get all these keys, only the keys from this map object, whatever the keys are there, I can get them by calling a method called as key set. Where I have to store them? I have to store them in a set. For example, how can I get all these keys now? I can get all these keys by writing a statement called set. Let's say, for example, keys set equal to map dot key set. This is a method. What's the method name? Key set. Key set method returns what? Only the keys from the map object, and we can store them into a set. Now, if I want to get only the values, now, these are all values now. Not complete all the values only, not their keys, only the values. If you want to retrieve only the values, then you have to store them in a collection object. So I can store collection. I can store in a collection. C is equal to map dot values. There are two methods I've covered here. One is called key set method. Next one is values method. Key set method returns all the keys of a map into a set. Okay. All the keys of a map object into a set. That's what key set method will do. What values method will do? Returns all the values of a map object into a collection. That's what the two methods I covered here, key set method and values method. Similarly, if I want to store not just only separately keys and values now, I want to get all these pairs. These pairs are also called as entries. So for example, if you want to get all these pairs, for example, now you want to get all these pairs. If you want to get all these pairs, both key and value, all the pairs, then you have to call one more method called as, entry set. Entry set method returns both key and value pairs. They are called entries. I told you now, each element is called one entry. One entry is nothing but a key and value combination. Combination of key and value is called one entry. There is a method called as entry set, which means I should call something like this. What should I call? Set of, for example, entries is my set name equal to map dot entry set. So three methods I've covered here. One method is key set. I've covered three methods here. One method is key set. Other method is values. Other method is entry set. Key set returns only the keys of a map object into a set. Values method returns only the values from a map object into a collection. Entry set method returns both the pairs of key and value pairs. That's what called as entry set method. So we have key set method, we have values method, and we have entry set method. These are the methods, the three methods I want to write in the document. And isEmpty method returns either Boolean value true or false. True or false. Okay, if the map is empty, returns false, returns true, otherwise returns false. So first, let me write all these methods. Now first isEmpty. What this isEmpty method do? Returns true if the map contains no key value pairs. Returns true if the map contains no key value pairs. Otherwise, returns false. That's the first one, is empty. Next one, key set. I told just now what the key set method returns. Returns a set with all the keys from the map object. Returns a set with all the keys from the map object. But it will store all the map keys into a set. That's what key set method will do. Key set returns keys. Values method returns values. Values method returns collection object, not this set. So the next method is values. Returns a collection. Returns a collection with all the values from the map object. Next, seventh method is entry set. Okay, entry set returns the entries are returns a set with all the entries. Entries are nothing but key and value pairs. That's called entries. Not only keys, not only values, both key values. Key value pairs. Entries are nothing but key value pairs. A set with all the entries of the map object. So there are methods like key set, values, and entry set. Key set returns only keys. Values method returns only values. Entry set returns both key and values. That's the difference between the three. First, let me keep them in a bold letter so that you people can identify the method names. Okay, right. And if you take, for example, hash map, the capacity is 16, load factor is 0.75. I'll write the statements, but actually it is not required. Okay, right. So next we'll discuss about if any other methods, if they are useful for us. These are useful methods. Entry set method I have just now explained you. Next. Clear is a method removes all mappings at a time. Remove for removing one key value pair. But if you want to remove all the key value pairs at a time, then go for clear method. Size method returns the number of key value pairs in the map object. So there are two more methods which I will like to add. One is, okay, eighth method, that is, what's the method that we want to add? That is, okay, size method. Size method. What size method returns? Size method returns the number of key value pairs in the map object. Okay, the next method that we want to discuss, that is clear. What clear method removes all the key value pairs from the map object. That's all. Enough now. These are the common methods for hash map, linked hash map, hash table, or to the tree map for all of them. Okay, and you know already difference between hash table and difference between hash set and linked hash set. Hash set does not maintain the elements in the insertion order, but linked hash set maintains elements in insertion order, because linked hash set elements contain previous and next links also. So I gave even the diagram also, you can go through. Linked hash set can maintain insertion order of the elements, but hash set does not maintain. Similarly, the difference between hash map and linked hash map is what? Hash map cannot maintain insertion order of the key value pairs, but linked hash map will maintain insertion order, because linked hash map contains what? Not only key value, it also contains previous and next links. So linked hash map is a linked list implementation of map. Okay, so that's why it maintains insertion order, but hash map does not maintain insertion order of the elements. Okay. And how does the element get stored in the map object? Actually based on first hash code, bucket index. How does bucket index calculated? First hash code of the key is calculated. First hash code of the key is calculated. Based on the hash code of the key, bucket index is calculated. Then the key value pair will be stored in the map object. Okay. The difference is what in hash set internal uses hash map only now. But in hash set we are only adding one element, but we are not passing key value. That's why present will be stored as a value there. Present is a dummy object. Whatever value I gave, that will be stored as a key. And present is a value, key value. That is set. Internal uses map only. Similarly, when we come to hash map, we can store key and value by ourselves. Here, present is not the value. Our value is the value. There is a difference now. You people can catch this point. Okay. Just what I'm trying to say is now, like a question I want to add better. Question is how does a key value pair will be stored in a map? In a map object means it could be hash map object or linked hash map object or tree map object, anything. All are map objects only, or even hash table also. Okay, the answer to know. Okay, the answer to know is now what is calculated first? First, hash code of the key, not the value of the key only. Because again, that is also important. For value hash code is calculated or for the key hash code is calculated. For the key, first hash code of the key is calculated. Okay, first what? Hash code of the key is calculated. Okay, once a hash code is calculated, what next? Once hash code of the key is calculated. So first a hash code of the key is calculated. Okay. Then bucket index is calculated. Based on the key, based on hash code. Okay, the bucket index is calculated based on the hash code. Then the element is nothing but what? Key and value, no? Element is nothing but key value. Both are called element, right? Then the element will be stored into that bucket or into that bucket index. That bucket index. That's how it will be stored in the map object. Okay. Next, you know already these are common questions now. Whether it is a tree map, hash map, linked hash map, anyone. What the common thing? Common question is what? Default capacity and load factor. Next question is. Okay. What is the default? What is the default initial capacity and a load factor of a map object? Answer. Default initial capacity is 16. The default initial capacity is what? Is 16. And the load factor is 0.75. Am I clear with you guys? The default initial capacity is 16 and the load factor is 0.75. Okay. Right. These already we know. And when the size gets doubled, capacity into load factor. Formula. Capacity is 16, load factor 0.75. 16 into 0.75 means 12. Means what? After 12 elements are filled, if the 12 elements are filled in the map object, then the map object size capacity gets doubled. The capacity. Size returns number of elements, whether 5 key value pairs are there or 8 key value pairs are there, that is size. Capacity means how many elements it can store max. That's what capacity. Okay, right. Are you getting my point? Okay, good. So this already we discussed at the time of set concept. That's why it's going to be very easy for us and we'll discuss. And in the hierarchy, along with the sorted map, actually one more is missed out. That is, I'll talk about separately. That is what concurrent hash map. That also we will discuss now. After tree map, I'll discuss concurrent hash map. Concurrent hash map diagram is missed in this. I forgot to add the concurrent hash map. There is a concurrent map interface, and there is a concurrent hash map is a class. Okay, so that is one thing missed out, but okay, I will add that separately in the document next at the time of discussing concurrent hash map. Okay, right. So you got to know about something for today, and we'll further continue tomorrow. I'm saying tomorrow, which means we have the class tomorrow also. Okay, tomorrow also we have the class. Okay, at the same time. Okay, please attend the class tomorrow at the same time. Okay, I'll take the class tomorrow also. Okay, from 7:30, I'll start the class at 7:30. From 7:30 to 9, we have the class tomorrow. Okay, please join.
Sir, advanced Java, when will be started, sir? Your batch?
That as of now, no schedule, tentative schedule is there. Please connect with admin ones. Maybe they know when they are planning for the batch date and all, time, date and all. Okay, please connect with the admin. Okay, Shilpa. Okay, guys, tomorrow we'll continue. Thank you. Tomorrow we'll continue with the continuation part of this. Tomorrow we'll try to discuss all this hash map, linked hash map, tree map. All these things we'll cover tomorrow, so that next concurrent hash map I'll explain about on Monday. So probably we'll try to complete the collections concept on Monday. We'll try to complete or close the collections on Monday. Once you got to know collections, then from Tuesday we can start with the Java 8 features. Okay, thank you. Tomorrow connected same time, 7:30. Thank you.
Okay, sir. Thank you.